Hello and welcome back to this course. We just want to talk about the optimization. Since we just wanted to solve some optimization problem via metaheuristics, we have to know about this terminology because this terminology would be quite critical and important for our course. And actually, once we just want to talk about optimization, we have to know about objective function. What is objective function? Objective function, actually, we just wanted to minimize or maximize something with respect to some elements or set. And we have also decision variables. We have a different and wide range of decision variables, such as binary decision variable or continuous decision variable. So it would be different from problem to problem. We have also some constraint, and these constraints formulated as mathematical equations and can be solved graphically or using some commercial solver. And this is the main elements of any optimization problem. So for any given optimization problem, we have an objective function, and it would be maximize a profit or minimize a cost, or it would be optimal design for any engineering design. And it also contains some decision variable with respect to some equation, and it can be called as a constraint. We can say that optimization problem would be a problem or solution procedure which aims to find the optimal solution to the objective function or function under some constraints. If we just consider objective function, we have some classifications such as this. Sometimes we have a single objective function, so it could be minimization or maximization, or we may have to simultaneously solve bio objectives. So we have a multi-objective function, so it could be minimization, maximization, and maximization. And in new trends, in most real-world cases, we have many objective functions. So this kind of objective function would be quite practical, and it's really complicated to be solved. So once we have more than two objective function, we can say that we have many objective function, and there are some approximation approach to solve this kind of problems. So to better understand the optimization problem, I will give you a small example for the real life example. It would be a real life example. So suppose that you wanted to purchasing a car, so you may consider different criteria, and you may consider environmental issue. If you are an environmentalist, so you may consider the type of fuel or amount of emissions, or you may just consider the brand of the car because you just taken into consideration which brands would be important for you. It may be related to your personality, or you may for yourself, it may be important with which type of car would you want it to be purchased. It may be SUV, sedan, or off-road. So this kind of condition you may have once you wanted to buy or purchase a new car. So we have a mathematical model component for this decision making, and you just wanted to, for example, minimize the general cost. Once you want to buy a car, it would be objective function, and you may have some constraints such as limited set of brands and type of cars, or some environmental considerations you may take into consideration. So it would be binary variables that this car, this brand would be selected or not. So this is a simple optimization problem that you may have in your real life problem. I'll just give you this example to understand better optimization problem. So it can be used for any discipline, for example, computer science, business, or operational research, economics. So, and this kind of problems, it widely used. This is a small example of mathematical optimization problems. So this is a minimization problem, and it is a mean z, which is equal to times x plus 3 times y. We have two constraints here, and we have also two decision variables, x and y would be real or continuous. So this kind of problem, this kind of equation or objective function is linear, but just bear in mind that it could be non-linear for some problems. We have also a linear equation for constraint, but it could be non-linear. So for non-linear objective function or for non-linear constraint, the problem would be more complicated. And for decision variable, we have a continuous decision variable here, but it may be integer decision variable or binary decision variable. There are different conditions once we want to have a mathematical programming, and it's depend on our situation. We have a different kind of optimization problems. So it may a question arise and how we can solve this kind of problem. The most simple and straightforward method would be in the manual methods, such as a simplex or graphical method. It could be easy to use, but it cannot be applicable because most optimization problems is so hard to use this kind of method. And the second approach would be computer solvers such as simplex or GAMS or something like that. For the large scale problems, we have some problem to solve this kind of, to use this kind of solver. And the last one would be the approximation approach, and it could be more applicable. Just bear in mind that we in most cases that we cannot obtain optimal solution, we just obtain near optimal solution. So it should be said that the most efficient method would be just drop it in the last category. And as you know that optimization problem have a different applications. There are many manufacturing problems that can be solved via optimization approaches, and we have also some optimization problem related to the logistics, and we have also some problems that can be dropped in finance, and we have also some engineering problems that can be taken into account to the optimization problem. We have also wide range of supply chain problems that can be expressed as mathematical programming. We have also implement optimization in artificial intelligence. We have also implement in science such as physics and chemistry. So this approach, this terminology can be applied in all disciplines. So we have many different applications for the optimization problems, and we have many other applications for optimization problem. This is an introduction of the optimization problem. Thank you so much for your attention.